So welcome back guys. In this module we will going to learn about layer 3 routing, which is also called as L3 routing. So we will discuss layer 3 routing, that is routing done by the network layer of the TCP/IP stack, right? And always remember that layer 3 routing is all about routing being done by IP addresses. So remember, L3 routing are done on the basis of IP addresses only. The MAC addresses are completely out of question. They simply do not play any role in L3 routing. MAC addresses are restricted only to layer 2 routing, right? So layer 3 routing means that routing done from one layer 3 router which is connected to source subnet to layer 3 router connected to destination subnet. So always remember that layer 3 routing is all about routing a packet from one subnet to another subnet, right? So here source subnet is a subnet in which source machine is present, and destination subnet is a subnet in which destination machine is present, right? So here layer 3 routing means that routing a packet from a router which is connected to a source subnet to a router which is connected to destination subnet, right? And in between these two routers there could be any number of layer 3 routers, or there could be an internet between these two routers. So in this module we will going to learn that what are exactly layer 3 routes, how do we install and configure the layer 3 routes in Linux virtual machines, and how layer 3 routes help us in achieving layer 3 routing. So going forward, you can see this is a simple topology, right? So in this topology I have shown two subnets. On the left hand side we have a source subnet X, right? And the network ID of this subnet is 11.1.1.0/24. On the right hand side we have a destination subnet Y, and the network ID of this subnet is 12.1.1.0/24. Right? Now we know that every subnet is gated by an L3 router. So for a source subnet X, layer 3 router R1 is a gateway router for subnet X. Similarly, for subnet Y, the layer 3 router R2 is a gateway router for subnet Y. And let us say that in our example, machine B is a source machine and machine F is a destination machine. Meaning that source machine wants to send a data to the machine F which is present in subnet Y. Meaning that source machine B which is present in subnet X wants to send data to machine F which is present in subnet Y. And remember, in between these two subnets there is an internet. So internet means any number of L3 routers can be there in between these two subnets, including L3 router R1 and R2. So always assume internet as a network in which infinite number of layer 3 routers are present. Now going forward, machine B, which is a source machine, wants to send a data to a destination machine F, right? Now clearly the destination machine F is present in a remote subnet with respect to machine B. So whenever a machine wants to send a data to a remote machine which is present outside its local subnet, the source machine has to send a data to the gateway router first. So sending a data by a source machine to a layer 3 gateway router is done by L2 routing only. So machine B is sending a data to a gateway router R1 using L2 routing. So remember, the packet has to go to gateway L3 router first if the packet has to leave its local subnet. So in this case, the source machine B has to send a data packet to its gateway layer 3 router R1 because the packet is destined to a machine which belongs to a remote subnet. Now once the packet reaches L3 router R1, the L3 router R1 has the responsibility to send the data to the next layer 3 router in the network based on its layer 3 routing information. Now once the packet reaches layer 3 router R1, henceforth the journey of the packet is now done using layer 3 routing. So it is the router R1's responsibility to send or forward the data packet further to the next router in the network based on the layer 3 routing information it has. So simply layer 3 router R1 forwards the packet to the next router present in the internet. And as we already know that internet is actually a network of large number of layer 3 routers. So every router in the internet will going to forward the packet to the next router in the network based on its layer 3 routing information. And by repeating this process, the packet eventually reaches the layer 3 router R2, which is the gateway router of the destination subnet. So you can see that journey of the packet between the router R1 and the router R2 is done based on layer 3 routing, right? So using layer 3 routing only, the packet travels from router R1 and eventually reaches the router R2, which is the gateway router of the destination machine. Now, once the packet reaches the layer 3 router R2, the router R2 has the intelligence to find that the packet actually belongs to one of the local machine present in its directly connected subnet. Now the destination subnet Y is actually a directly connected subnet of router R2. So now router R2 knows that the packet has to be delivered to some destination machine present on the subnet Y. So henceforth, the journey of the packet from the router R2 to the destination machine F is again accomplished by layer 2 routing. So you can see that when the packet travels from the source machine to the destination machine, there is an L2 routing followed by layer 3 routing followed by L2 routing again. The first instance of layer 2 routing is responsible to take the packet from the source machine to the gateway router R1. Then layer 3 routing is responsible to take the packet from layer 3 router R1, that is the source gateway router, to the destination gateway router, right? And once the packet reaches the destination gateway router, the layer 2 routing again comes into the picture, and layer 2 routing again is responsible to take the packet from the destination gateway router R2 to the actual destination machine. So we will going to discuss all this process more elaboratively and in detail, that exactly how layer 3 routing happens in the network. So with this illustration, I think I am able to explain the role of layer 2 routing and layer 3 routing in taking a packet from the source machine to destination machine, given that source and destination machines are present in different subnets